Hi, you're listening to Mike Stanzik, and this is Digital Electronics Classroom. This video, we're going to do an Ohm's Law lab, and we're going to do the lab part of the Ohm's Law lab, where we're going to take the data. We're going to take 5 data points, and so it's a little bit low, but just to give you an example of how we would take this data, if I was really doing this to get a good representation of the model for the element that I'm testing, I'd probably take more data points. So what is Ohm's Law? Ohm's Law says, well, if we have an element, and this happens to be what we call a resistor, if we put a voltage across it, we get some current going through it. And so we want to look at the relationship between the amount of current that travels through the resistor dependent upon how much voltage we put across it. So we have some equipment here. We have a breadboard in which our resistor is plugged into. We have some jumper wires that allow us to connect to the resistor. We also have over here a voltage source or power source. And we have 2 multimeters, and I've labeled these multimeters as beige and blue so that when we look at the circuit, we understand which one is connected to each. Now, to make some dependency analysis about how the current is affected by the voltage, we have to measure current and voltage. And so how do we do that? Well, we have to make sure that we're doing that in the proper way. So I'm going to draw a little circuit here on this whiteboard so that we can see kind of how we're going to connect this all together. And so first off, we have our battery, our power supply. So our power supply, we draw like this. Okay, so this is going to provide some voltage. This is the power supply. Okay. And then we're going to connect this power supply to our resistor. And I'm going to also draw the resistor in blue. And the resistor gets this zigzag pattern right there. And this is our resistor. And then we're going to have our wires. And so the wires are connected. There's going to be the jumper, that's the black jumper, like that. And then this is the jumper, that's the red jumper. Like this. Okay? And so that's what it looks like in our circuit. Now, when we connect our voltmeter and our ammeter, we're going to be connecting them into this circuit. Now, the voltmeter is nice and easy. We can connect it in parallel. And so let's go ahead and do that. So this is going to be the voltmeter. We're going to connect to one part of the wire right here. This is going to be our positive voltmeter measurement, and then we're going to connect to the other wire with the black end right there, and this is going to be our negative voltmeter measurement. And so we can just measure, we want to measure the difference in the energy of the electrons or the charges on this side compared to the energy of the charges on that side. So we connect to both sides to look at that difference in energy, and that's our voltage. And so that whole connection there is our voltmeter. So these are being connected to the voltmeter. Okay. To measure the current, though, we want to see how much of the charges go through this element. So we have to connect this in what's called series. We have to make sure that it sits afterwards or before, so that any current that goes through the resistor also goes through our measurement device. And so that requires us to break the circuit. So we're going to break this circuit to plug in our ammeter. So we're going to break it. So we're going to break that circuit. Okay, for the ammeter. And then we'll connect our ammeter at that location. So this will be the, say, positive side of the ammeter. And then it'll go through the device, right, like this. And then it'll come out the negative side right here and then connect back into the circuit. So whatever current is going to go through the resistor, so whatever goes through here will continue on and go through the device, and that's what we want. Okay? And the voltmeter up here measures the difference across the device, and then the ammeter measures the current through the device. And so that's what we're going to be doing. as we connect everything into our circuit. Okay, so let's go ahead and start to connect this up. So first off, I'm going to put the wire into the resistors here. I put it in the same row so that it'll be connected. And so this wire is going to be broken off a little bit, so I'm going to just leave it kind of hanging for the moment. Okay, and then I'm going to connect my power supply. So this is the connection of the power supply, so it goes to the red wire. So we'll connect it over here to this red wire. And then the black part of it goes to the black wire, so we'll connect it over here to this black wire. Okay, great. So now we have the power supply and both wires. And so now we have the resistor in there. So the next thing we have to do is connect in the voltmeter and the ammeter. So let's do the ammeter first. And so the ammeter needs to connect here to the other side of the resistor. And so there we'll connect it to the other side of the resistor, like so. And then the black part of the ammeter is going to connect to the black jumper wire. And so we'll connect that here to the black jumper wire. These little micro grabbers, which are awesome. Okay, perfect, we got that. So now we have the ammeter in. The only thing we have to do now is put the voltmeter, and that goes on one side and the other side of the resistor. And so I'll connect the voltmeter. And let's point out here that the ammeter has the blue markers, and then the voltmeter has the beige markers. And so I'll connect the red one to the top part, or the red side of the resistor there, as we have it marked. And then we'll connect the black probe to the black side of the resistor, like that. Okay, perfect. So now I'm going to take some data, and I'll make a little chart over here on the right side. I don't know if you'll be able to see this, but this will be where we'll record our data. Lots of wires in the way. And so I'm going to have a voltage and a current. And we'll measure both of those values, and we'll do that 5 times. All right, so let's go ahead and start to apply a little bit of voltage here. So I got about 1 volt applied, and let's make sure that we are in the range that we want to be in. And so let's see, that's auto range there, I think. Why is it not allowing me to do that? Okay, function, milliamps, okay, that's what I want. And then we're going to do 50 milliamps. Okay, so that will be a good range for us. Okay, so now, even though this says 1.01 volts on the power supply, we're not going to trust that value. We're going to trust our multimeter values that are reading right at the resistor. And so here's our voltage multimeter value. It's 1.0276. Now I'm not going to go to that many decimal places, so I'll go to 2 decimal places, so that'll be 1.03 volts. So my first measurement, I have 1.03 volts as the measurement there. So we're going to measure here in volts. And then here's my current. Now the current is in milliamps DC, and it says 1.52 milliamps DC. So 1.52. And then I'm going to put that unit as milliamps. Now when I do my analysis, I have to make sure that I understand that I'm using something less than 1 amp. I'm using milliamps, or 1,000th of an amp, when I look at that value. Okay. Now we're going to change our voltage value to about 2 volts and see what we get there. So there's 2.05 volts. Oops, I wrote that in the wrong side. Let's go ahead and do the good old finger erase. Perfect. So 2.05 volts gives us 3.04 milliamps. And let's go up to about 4 volts. And so we got got it pretty close, 4.01. 4.01 volts gives us 5.93 milliamps. And now let's go up to about 8 volts. And 8.10 gives me 11, I think I knocked it there, 11.8. Let's just go 3 digits here, 11.8 milliamps. And then we'll take one more, and I'll go up here to about 12 volts. And so we have 11.9 volts and 17.8, and I'm going to put, oh no, there you go, 17.8 milliamps. Perfect. Okay, so we have our 5 data points, and this will allow us to put this into a table and a graph, and then do some analysis about the big question. Now, if you've forgotten the big question, our question is, how does this device respond to a voltage across it in terms of how much current flows through it? So how does the current flow flowing through this device depend upon the voltage that is put across it? That is our big question, and we'll answer that in our next video. Thanks for watching. I hope you enjoyed this little lab setup and taking some data, and as always, have a wonderful day.